In many ways, the atmosphere around us behaves like a fluid. Ocean waves that begin to crest at the beach are analogous to a unique set of atmospheric waves called Rossby waves. Dr. Kevin Bowley studies the similarities between the two as his core research revolves around large-scale weather patterns known as synoptic meteorology.
These waves that are propagating their way inshore, eventually they reach a point where they kind of slow down a little bit. And when they slow down, they kind of stack up and they eventually crest and break and kind of lose their shape overall. And the same thing happens with our waves in the atmosphere. So that's kind of at its core what a Rossby wave breaking event is.
Bowley's most recent synoptic research topic revolves around Rossby waves, which form from areas of high pressure and low pressure. According to Bowley, Rossby wave breaking events can simultaneously deplete and form large amounts of atmospheric energy for weather systems to tap into.
If you flip that question around, if we have storms that can deplete energy, do we also have storms that can increase the energy? And what we found is that there's not necessarily storms per se, but certain patterns. This idea of Rossby wave breaking can actually have a process that leads towards an increase in that energy at the exact same time scale.
When Rossby waves rotate counterclockwise, rising motion can occasionally cause intense mid-latitude surface low-pressure systems like nor'easters to form. Alternatively, when these waves rotate clockwise, sinking motion can result in intense high-pressure systems. This can result in Rossby wave blocking events where prolonged heat waves and suffocating air quality can occur. When Bowley pursued his PhD, he studied zonal available potential energy, which describes how large changes in temperatures over a region can create more atmospheric energy. This energy originates from Rossby waves and have been known to fuel some of the most notorious synoptic scale storms in the northeastern United States. For example, the March 1993 superstorm dropped 20 to 30 inches of snowfall throughout central Pennsylvania.
That happened to be in a scenario where we had anomalously high or abnormally high amounts of available potential energy, and that storm very heavily depleted the energy of the atmosphere.
Also, Bowley plans to apply his research towards studying climate models. His goal is to see the evolution of Rossby waves from previous years and compare them to model projections.
My hope is that my work and the work that we do here in the department will help to prescribe how people can make informed decisions, how they can make smart decisions about how things are changing, how that's going to impact their day-to-day, but also how it's going to impact the day-to-day of whether or not their package will arrive, whether or not their car will be able to work the way it does.
Ultimately, Bowley hopes that his research will help improve how models predict areas of intense high and low pressure systems. An increased understanding of these future events is critical to help people be more prepared. For Whether or Not, I'm Ryan DePhillips.